Hi, everyone. My name's Kurt Roloff, and I'm the CTO and co-founder of Duality Technologies. Duality, we're a venture-backed startup. We actually happen to be using transition of technology that our core team developed at DARPA about a decade or so ago, and bringing out into the world to help do things like fight financial crimes and help support other aspects of national security. But a core part of what we do is using an underlying technology called homomorphic encryption to help both provide privacy, security, and help span information domains while maintaining privacy and security. The core concept of this is that it is difficult for organizations to share and collaborate on sensitive data needed to make critical decisions. This, of course, has military applications, such as how does one collaborate with coalition partners at multiple levels of security? How does one, for example, collaborate with other departments of government, such as the CDC, such as Department of Treasury, Department of Justice, and so forth, to help further the missions of national security inside the government, writ large and broadly. So there's a few ways of doing this that we've come out with, but one in particular is this technique called fully homomorphic encryption, which is what the previous speaker alluded to in the end. And we're supporting this with a number of use cases. The concept of FHE, also called fully homomorphic encryption, is that it enables data to be computed on while the data is protected by encryption. And the concept is that you could take a photo, encrypt that photo, send that encrypted photo, and only an encrypted photo, up to a generic cloud, say like Amazon, GCP, Azure, and so forth. You can run a facial recognition algorithm on that encrypted photo without sharing keys, without decrypting up on the cloud, and then get an encrypted result. Then take the decrypted result back, say bring it onto your phone, run the decryption algorithm, and have a facial recognition result come out of it as it is. This is a pretty powerful concept, and it does allow a lot of very generic sets of capabilities. Commercially, we're deploying this to support things like secure database queries, with the queries being encrypted to maintain things like operational security, and in addition to both inference on encrypted models, such as convolutional neural nets, and training on convolutional neural nets in the DEPRIVE program, which was alluded to earlier. Of course, the challenge with this technology is that the very heavy workloads require a lot of compute power, hence why I'm speaking in an MTO program. Oops. So as part of that, we are executing on the DEPRIVE program on a team called Trebuchet that we're running with ISI, II-VI, and several other core partners, to design a processor architecture that accelerates FHE to multiple orders of magnitude. Basically, what this does is it balances the ability to compute, communicate, and use very heavy memory. One of the challenges, particularly why this is an MTO, besides the compute power, is that the encrypted data is very large. It requires a lot of memory. It deals with very large bit width type operations, and a lot of very interesting architecture challenges as they are too. And myself and any of the other performers in the program will be very happy to talk about this offline as it is. But it's not just about compute, and that allows a lot of other applications relevant to the DoD as it is also. We're also supporting a project in I2O called Ops5G that allows you to basically start performing secure network slicing on things like 5G networks. The vision as part of this is that you could take a generic network, commercial network, might not even be a network inside the US, run on top of 5G hardware that you might not control, and then create secure slices on that hardware using this homomorphic encryption technology to basically create a secure network overlay on top of what might not be actually secure as it is too. Of course, the use cases for these kinds of technologies are tremendous, besides just the pure processing, machine learning, network security. And of course, I'm very happy to talk offline, during the coming breaks as it is. So thank you very much for your time, and have a great day.